Let's discuss about the next parameter for an ellipse, that is latus rectum. So we'll discuss about the latus rectum. Now for an ellipse, how does the rectum is going to look like? Remember, latus rectum is a line which is perpendicular to the axis and which passes through the focus, correct? That is basically a latus rectum. In the sense, in our case, assume that you have the y-axis and x-axis, something like this. Okay, now we'll look into the ellipse. So assume that this is going to be the ellipse what we have. All right. So for an ellipse, something like this, we have the focus. Say, assume that this is the focus. Now a line perpendicular to the axis, and also it has to pass through the focus. That is basically a latus rectum. So in our case, a line which moves something like this. See, this is going to be the latus rectum. Since an ellipse has two foci, one to the right, one to the left. So say this point is f dash. And here also we are going to have a line. Fair enough. Say this point is A, this is B, say this is C, say this is D. Alright. Now, we are trying to calculate the length of the latus rectum, isn't it? For that, what we'll do, we need the, see, length, how can you calculate with the help of coordinates? Fair enough. Now, F is given by, the focus is given by C, 0. Correct? Let's assume that FA, the distance what we have, this distance, let's call that distance as L. Okay, so that AB becomes 2L because it is symmetric, isn't it? Now what we have, since we are trying to calculate the total length, AB distance, for that, first let's try to calculate what is L so that we can just double it afterwards. For that, see, the coordinates of A is going to be C, L. Now let me explain why this is C, L. To come to point A, what do? First, from origin O, you move to F. Then from F, you move to A. Correct? So O to F is what? C. F to A is what? L. So what will be the coordinates and what should be the coordinates of A? It has to be C, L, isn't it? Now that we have the coordinates of A, now what do? A is a point on the ellipse, correct? And the equation of ellipse is what? We have x square by A square plus y square by B square is equal to 1. This is the equation of the ellipse. Now, in place of x, we can put C. In place of y, we can put L, isn't it? So, we are going to get C square by A square plus L square by B square is equal to 1. But in the previous video, we have discussed about eccentricity. That means here, C can be written as AE, isn't it? So we can write this as AE whole square divided by A square plus L square by B square is equal to 1. A square gets cancelled. That means we end up with E square plus L square by B square is equal to 1. Or you can write L square by B square is equal to 1 minus E square. Correct? Or L square is equal to B square into 1 minus E square. Fair enough. This is what we are going to get. L square is equal to B square into 1 minus E square. Okay, now we need to simplify this a little more further. Like, of course, we have to take the root, isn't it? But before taking the root, we'll figure out what can be done here. What we got was L square is equal to B square into 1 minus E square, isn't it? Now, suppose if we have to do, see, E square is present. But what is E? E is equal to C divided by A, or E square is equal to C square by A square, isn't it? We have this, but what is C? C square is equal to A square minus B square. If you remember from the derivation of the ellipse, that means E square is equal to A square minus B square by A square, which gives us 1 minus B square by A square. See, if E square is 1 minus B square by A square, we can substitute that here, correct? So what we'll get? We'll get L square is equal to B square into 1 minus of 1 minus B square by A square, correct? Now, see, the 1 and 1 gets cancelled. You get B square into B square minus A square, which becomes B power 4 divided by A square. See, if L square is B power 4 by A square, then we'll take the square root because we need the value of L, right? So, L value is going to become root of B power 4 by A square. So, this is power 4 by the way. Now, distance cannot be negative, so we can't take the plus or minus, it's just plus. So, what do we end up with? L is equal to B square divided by A, correct? This is, remember, this is just a half the length. So, what will be the total value? So, total, that is the lattice rectum, is equal to 2B square divided by A. And this is going to give us the total length of the lattice rectum. So, above is L, below is L. So, total is going to be 2L, which is going to give us this particular value, 2B square divided by A. Now, suppose if the ellipse has the major axis as y-axis, x square by b square form, then the lattice rectum will become 2a square divided by b. Fair enough? So, lattice rectum for the given ellipse, whatever we have, in the sense, the major axis being the x-axis. For that particular ellipse, the length of the lattice rectum will be 2b square divided by a. Same thing if you have an ellipse with y-axis as the major axis, then the length of the lattice rectum will be 2a square divided by b. Fair enough? Now we have all the parameters related to ellipse. Correct? We did the equation x square by a square plus y square by b square is 1. Then we did the foci in this case. C is equal to what? A into E. That means we are introduced to the next concept of eccentricity. Then after eccentricity, all the major axis, minor axis, the foci, the vertex, the center, everything. Then along with that, we have the next parameter, which is the lattice rectum. So lattice rectum is 2b square divided by a. So with all these parameters for an ellipse, in the next one, we'll do some of the problems based on whatever concepts we have learnt.